Hello guys, today's program is about Java abstract classes. It is basically a tutorial on what are the abstract classes in object-oriented programming of Java. And we will implement an application that is based on geometric shapes, and it will have two hierarchical subtrees that will extend the abstract classes, and we will see how abstract classes will be used in the Java programming. Let's begin with the introduction of abstract classes. Introduction. An abstract class must be declared with the abstract keyword. Can have abstract or non-abstract methods. Every abstract class can have abstract or non-abstract methods. If a class has an abstract method, it must be declared abstract. Cannot be instantiated or invoked. An abstract class cannot be created and cannot be invoked. It must be extended or inherited to be used. It can have final methods. Final methods are special methods that we cannot overwrite. Abstract classes can have constructors. We can even chain the constructors. We can even call the superclass or parent class constructors, and we can also chain the local constructors. Can have static attributes and can have static methods also that we can call by the name of class. Can extend or inherit from another class. And we know that Java can only extend or inherit from one other class, one immediate parent class. Can implement one or more interfaces. Any abstract or non-abstract class can implement one or more interfaces. Abstract class can be used as a reference to store the derived class objects. We can use a parent abstract class reference to hold the objects of child classes. Now the application that we will demonstrate the use of abstract classes. We will write geometric shapes. Shape will be the parent base class, and there will be two more abstract classes that will represent 2D shape and the 3D shape. And we know that in geometry we have 2D shapes and 3D shapes. 2D shape has its own hierarchical subtree, and similarly 3D shape will have its own hierarchy. These are the classes we are going to implement. We will write the 2D shapes that will be the abstract class for the 2D shape classes. This will extend the base shape class. Circle, rectangle, triangle, and square. These will be the concrete classes in the 2D shapes hierarchy. Then we will write a 3D shape base class that will extend the shape class, and it will be a abstract class and extended by the sphere, box, cube, and cylinder. These will be the four 3D shape classes that we will implement. This is the hierarchy. Shape at the top class, this is abstract. 2D shape and 3D shape. These two will extend the shape class, but they will also be abstract classes. Then we will have the concrete classes. 4 classes from the 2D shape and 4 classes from the 3D shape. Sphere, cylinder, cube, and box, rectangle, square, circle, triangle. We will try to put the common functionality and the attributes into parent classes as much as possible. Let's see the mathematical formulas to compute the perimeter, surface area, and volume of these shapes. Now, for the 2D shapes, we used to calculate area and perimeter. For 3D shapes, we calculate surface area and the volume. So circle, rectangle, square and triangle. We will calculate area and perimeter. These are the standard mathematical formulas that we will use. And for the 3D shapes, box, cube, sphere and cylinder, we will calculate surface area and we will calculate the volume using these formulas. Let's begin coding. I am going to divide this application into 3 videos. First, I will implement base classes, 3 base classes, and then in the next video I will implement the 2D shapes and we will test them. In the third video, I will implement 4 3D shape classes and we will test them and continue till the end of 3 videos. Thank you guys. Let's begin coding. So we add classes. I created this project with one main class, geometric shapes. I will write main method into it. So we will use it for testing the 2D and 3D shapes. So let's add a package first. Java package. 2D shapes. And 3D shapes. We always write package names at a lowercase as a Java convention. And we create class, base class. Okay, base class shape. Keep it in the default package. And 2D shapes. .2D shape class, that will be the parent class for the 2D shapes. And then I will add the circle class and rectangle class. Rectangle and square and triangle. Here cube, box and sphere and the cylinder, and one left is base class 3D shape. Okay, now first class. Okay, this is the base class, base of all the geometric shapes. Let's put very common things into it. Let's say name and XY coordinates of center. Private string name, private double, let's keep it integers, int x, private int y. Let's write a constructor, public shape. This is default constructor. Public shape string name int x, int y for the center. We can locally chain constructors. Like this, we can call the other constructor from the same class. This is called local constructor chaining. It is very powerful concept of object-oriented programming. Okay, instantiate shape with given parameter values. This dot name is equal to name, this dot x is equal to x, and this dot y is equal to y. We can insert these things by calling source generate function insert code like this, but it is better we write it here as a tutorial so that we can learn from it. So getter and setter functions, public string get name, return this dot name, get the name of the shape, shape name, set or update the name of the shape, name of shape. Putting Java docs is important. When we put Java docs, we can generate Java docs using the Java docs facility. And another important benefit of writing comments is that we can understand the code and we can explain the code. We can even write the formulas used within the functions, and it also help other coders to understand the code, and it increase the readability of the code. So it is very important. You must always put detailed comments within the Java code and any other programming code. Public int get x, return x, get the x coordinate of center. Center is the shape center. X coordinate. Set x int x, this dot x is equal to x. Set or update the x coordinate. Same way, public int get y, return y, public void set y int y, this dot y is equal to y. Set or update the y coordinate. Get the y coordinate of shape center. Return y coordinate. So this is our shape class. Now let's write toString function. Get the string representation or human readable information of the object. String representation. Okay, we can return string.format. Okay, let's say shape name. Now let's set some formatting. Percentage minus 20s, percentage s, percentage n, shape name and name. Okay, and we enter the let's print center %d that's it, center and xy. This will return something like this. Shape name, name of shape, and center and x and y values. That's it. Our shape class is complete. Let's make it abstract class. Abstract class. Let's implement 2D shape and 3D shape abstract classes. They will extend the shape class. Let's put the shape class into Java package. Let's say shape. Packages are important to categorize or classify classes and put the similar codes in the single package. Okay, refactor. Now we have the shape class inside shape package. Okay, we can easily extend this now. Extends shape import shape.shape. Okay, similarly we will do this to 3D shape. Import shape.shape and extend it. Extend shape. Now 2D shape. Common functions. We know that area and perimeter will be implemented in all the concrete classes, so we make them abstract. Public double calc perimeter. So this is abstract method. Function to calculate the perimeter of a 2D shape object. Return perimeter of the shape. Now the area. Public abstract double calc area, but don't need this body. Function to calculate the perimeter of a 2D shape object. Return area of the shape. Declare it as abstract. So we have this another abstract class. Okay, let's see if we can get common elements. Okay, circle has radius, width and length, side, height. No, we don't have an attribute that is common in all the 4 classes, so we don't need to put anything in this class for the attribute. So these functions are quite good to go. Okay, similarly we will implement the 3D shape. 3D shape will extend the shape class, and we have surface area function and the volume function. Public double calc surface area abstract function to compute the surface area of a 3D shape. Surface area public abstract double calc volume function to compute the volume of the 3D shape. Return volume. So we will override these functions in the child classes. These are the 3 abstract class that we are going to implement and extend in the next video for the 2D shape and next video for the 3D shapes. That's it, guys. Please subscribe to the channel and promote the content and comment and share. Thank you very much. Have a good day. See you in the next video.